Good morning, good afternoon, or good evening, depending upon where you live around the world. This is just an update from a previous video or two showing the quite incredible amount of detail or information held within a dome structure. And this, I would assume, is only, well, in fact, I can vouch that this isn't all of the angles that I can think of, because there are planes at which you may want to rotate the different disc, like I'm circling here. Now, I've actually created a wee mini version down the bottom here, and what this radial diagram is. And this is so that you can, say, a disc like this, now where do I want it to go? Well, if it's along the two sides, that's no problem, because I can rotate just using the native tool on all of them, but easily located on a surface. If it happened to be on the green, it would, a surface or axis along there, and of course the blue for the horizontal. But sometimes we want to orientate to this hub, this point here, or this point here. So we can have a line, and this is what this line is here, is at 45 degrees, is that I can select it, move my cursor along while keeping the left mouse button down, and now it will rotate whatever I want along a 45, like I'm doing here. And equally, when we come to these other hubs, these are at a specific angle, so I created a surface so that I can, again, go to rotate. I've got it on that surface. I push the shift button, it locks it into that surface. I can now click there, and when I rotate, it will rotate in the correct angle, and I can move it up into position. So that's jolly good, but I didn't actually include those because they're more of a background. It's not part of the geometry required for the dome. It's more of the function of drawing. Could put it in there, but really it would be redundant. But now you can see the angles I've achieved through a flat plane. The one that I showed for the ability to create accurate holes in the hubs, and you had to have these in a flat surface, and each one of them is going to be slightly different depending on its relationship to the sloping faces, and that's what we have over here. We've got the sloping faces with these angles in it, and we have the dihedral angles should you want to go down that path. And honestly, there's not much difference between the two, only 0.6 of a degree, and you wouldn't be worrying about that in the workshop, but knowing it, you can understand it better. There's not a lot of difference in the dihedral angles. That's all I'll come down, two and a bit degrees there, so it's only a 1 degree, not much. But I wanted to chase that down and create a reference or a resource for if there's something that's going to be required, if there's a mechanical requirement to maybe have a flashing bent up, we can, whatever reason, I don't know. But the last addition has been these ones. It's easy enough to do. As I say, I just rotate a disc up into position so that it is orientated in line with the radial lines, which means it's square to them. Lower the surface, the disc down, pop some, I'll just show you, pop some lines on where the honeycomb intersects it. Now, this is the beauty of this, now I have accurate lines as close as humanly possible within SketchUp. And as I said, SketchUp's brilliant at drawing it accurately. But when I measure it, these are precise measurements, but they're not necessarily accurate because of the small, very small glitch or inadequacies of SketchUp. I hate to say that because I think SketchUp's brilliant, but the inadequacies of SketchUp's measuring tools, well, at least in the free version that I'm using, the 2017 SketchUp Make. Because we have accurate lines, while these will be helpful, and they certainly will be when we go to use the indexing head, we only rely on the actual physical lines, which is pretty cool. So these are really I won't say redundant for our purposes, but have been relegated to a lesser need to know. So when we take this, we can print it out, and the beauty is if you take this and put it into a Word document or whatever word processor or some such, and then print to scale or fit to page, whatever you need to do within the Word document, print it out. We're only worried about the lines and not the proportions, because we can pop it on our piece of custom wood, making sure that the center is what we've got, is accurate, and proceed to, as in the last video, do what we need to do. And this is what we are talking about here. Is for those that have been following this series, well, good on you. But here we've got a couple of updates. We're showing that we've got a knob here that, when tightened, will squash this block onto the hub, making it locked in so it won't rotate. And this height of the block here is where the lines are rotated to, and as soon as you see it, a line, tighten it up, means you're in position. On the side here we've got a scale, so we've got 10, 20, 30 millimeters between these lines. You can in fact insert an engineer's rule, which is probably what I'd be doing. You can get those small 6-inch or 150 mil engineer's rules, and they go down to very fine increments, and so it's accurate, and it wouldn't be very hard to insert one of those into a piece of custom wood and use now these two plates are designed to hold down the custom wood base, and this is kind of like a sled where you can move it backwards and forwards through a screw adjuster here and fine tune it. So maybe one rotation will be 1 millimeter. So if you know that, you can assess it along the ruler, and by allowing yourself, just spin it round, move 5 or 6 millimeters different for the next hole alignment this way, then you're able to do that very easily. And this is a slightly wider base so that it can be clamped to the drill press base itself, because you don't want this moving around. And why you really do want to have, if you can, a center bit that's used for, as I mentioned, quite often used in engineering circles, in a lathe or in a drill press situation. You don't have a twist bit type drill bit where the way they're designed they can wobble or not give a accurate placement as these will, and that's why they're called a center bit, a centering bit. And some of them even have the tapers on them, or probably all do, where you can fit a centering tool, as in the end of it in a tailstock or some such. And these are all things that you can look at having for I think this is a simple setup. You'd probably bang this out in a couple of hours, and you'd be away laughing to be able to make these hubs. And then if you don't use it again, no big expense. You've got things that are really, really accurate, and no, as I say, no great expense, and you haven't had to get something specially made. I also see that Brian Proctor has a little jig, and he's the guy that I got this the idea from of the printing, the sheet. Well, he has a jig where I think you could go into mass production. So if you had to make lots of these, there's some ways that he's suggesting from his jigs that can be achieved. Now, the chances are that the people I'm making this for will make a one-off or maybe a two. That's probably their limit. So this would just be the bee's knees, as they say, for what you want. The other thing is, what size hub are you going to make? And as I'm talking, I've always referenced the 6 to 8 meter diameter or square base to my domes. You may wish to make a 1 meter square dome for maybe stretching or placing over some plants in your garden. So therefore you'd use maybe a say a 25 millimeter square piece of timber, and the attachment for that would be a lot less demanding, and where I think a 6 millimeter or 1/4 inch threaded rod bunged up the end of the strut into a wee ring of high density plastic plumbing type plastic tubing. Well, you could bang that in here too, and in short order you could place the accurately located holes for that and assemble the dome that way. So this has a lot going for it, and that's why I said earlier in this video, the information that I'm accruing as in here is a resource should you want to do some other iteration of a dome, one that best suits your situation, not for me, not for what I'm doing. Whereas I'm thinking more like this. It may well be that we need 4x4 or 100 by 100 millimeter or some such struts for a more demanding situation. No problem. Each time you alter your design parameters, this information is waiting in the background for you to use. It would be easy enough to make a 2x2 or 50 by 50 millimeter strut simply by dividing this strut in half, in quarters, doubling, but the information's held here again, the resource. Okay, well that's it. Just thought I'd give you an update for those that are following along. I don't know where the next video will be aimed towards. I hadn't anticipated doing this until I had to go back to thinking, well, if I'm going to step forward and make hubs, well, I need all those dimensions. So now we've got them. Okie dokie, well that'll be it for this one. I will see you in the next video talking about, I got no idea about what. Okay, and see you later. Bye.